and welcome to the Digital CxO podcast. I'm Amanda Razani, and I'm excited to be here today with Dr. Jason Corso. He is the co-founder of Voxel 51, as well as he is a professor of robotics and electrical engineering and computer science at the University of Michigan. How are you doing today?
Hey, Amanda, I'm doing great. How are you doing?
Doing well. Can you share a little bit about Voxel 51? What are y'all doing over there?
Sure. So Voxel 51 is a AI software company that builds a package called 51 and 51 teams for enterprise that essentially, our target user base are builders of visual AI that seek to understand more about their model performance and their data set quality so that they can ultimately make visual AI a reality. We've been open sourced since August of 2020. We have about 3 million installs. We do set up the software in a way that is hyper flexible, right? We don't sort of tell you what to do or how to do it. Think of it kind of like building blocks for the developer in the visual AI space. And, ultimately it's been used across various industries from, automotive industries to agriculture to consumer products, advertising, sports, you name it. We have users either in open source or enterprise.
Wonderful. Thanks for sharing. So, our topic of today is achieving almost 100% accuracy for visual AI. So, tell me a little bit about that and where you come in with that, and we can move on from there.
Sure. So, if you go to paperswithcode.com or, various leaderboards for computer vision and visual AI, sometimes the numbers will be jarring, right? Like the numbers might be something like 60% or 70%. And yet that's a decade of research that went into that level of performance, or decades of research, really, if you think about the pre-deep learning era too. Um, but if you think about what's necessary for actually deploying visual AI into practice, right? You have an autonomous vehicle, or you're doing a quality assurance on a manufacturing line. 70% is frankly not good enough. 80% is frankly not good enough. Even 90% is really not good enough, right? Like if you only miss 9 out of every 10 pedestrians that come into in your view in an autonomous vehicle, you're going to have some problems, right? So we think of this as analogous to the classical 5 nines concept, right? That's where the 99.999% comes from. It's from network security and network uptime, basically, in various pre-cloud in the pre-cloud era, and it is super critical to achieve that level of performance so that we can begin to assume robustness in various visual AI capabilities, and then take the harder problems to humans downstream, right? Whether or not that it is, I mean, I like the QA on the assembly line or the manufacturing line. Like it's a really good example, right? Like if you can basically have the humans, the domain experts who understand the product, understand how the circuit board needs to look, or whatever I just made a French press coffee, right? Like how the French press needs to be assembled, right? Like, and only give them the corner cases, their time will be used more effectively, and the overall efficiency of the manufacturing line will also be used more effectively. To do that, we want to get to this notion of 5 nines in visual AI.
So, once you have this very accurate visual AI, what are some use cases where this could be integrated?
Well, I mean, I think this really talks to or gets at the popular terms that are being used these days, right? So you have visual AI is one of them. Then we have this notion of physical AI, right? That ultimately, like what does the future of robots look like? Either take robots out of the factory and put them into the hospital, put them into the classroom, put them into the home. What can they do? And then even post physical AI, now we've also begun to hear about agentic AI, right? Like not only can these robots or these physical AI things see through visual AI and listen through language AI, but can they also begin to reason about the goals that are either given to them through conversation or taught to them in a training phase, to then go and understand what they should be doing to increase efficiency, or to help the elderly who's fallen down, or give the right medicine, or what have you, right? In order to reach those levels, you have to have a sturdy foundation, robust 99.99%. Visual AI is one of the elements, one of the key elements of those foundations, right? Like other elements are fast, low cost compute. We're getting there, right? The recent releases we've seen in January of 25, like from NVIDIA about, I think the system's called Digit. Like it's moving this notion of high power compute that in a more portable edge-based manner. I think that's one of the elements of the future. Another element is, like the ability to do speech recognition and speech generation robustly, to be able to interact with humans on the humans' terms. And we're seeing a huge amount of progress in that, right? The Whisper technology from OpenAI is like one of the latest in speech recognition, very capable. Still needs some work around speech or separation. Like if there's a robot amongst many humans, and like I have 3 kids in my home, so like many kids around making a lot of noise, like that gets a little bit more difficult. But once you have these pieces that are robust at the lower level, then we really we can begin to think about more practical physical AI and physically agentic AI in other applications. And I think that's ultimately the true impact, positive impact that AI will have to everyday life is not going to come until we've built those things first, or at least demonstrate that they are robust and safe and secure.
We're starting to see some self-driving cars around. When do you think it's going to be the case that almost every car is a self-driving car out on the road? How far are we from that?
Yeah, that's a hard question to really pin a time on. And anyone who has been confident enough to give a time has been wrong in the past. I think. Think about it another way, right? Like when elevators were first created, there were humans in the elevator to operate the elevator, and the elevator was still fully autonomous. It was just being operated by a human because that was the social contract, if you will. There was this comfort level. So I don't know exactly. I should look this up. I don't know when it became more common to have um, fully autonomous, no human operator in the elevator than not. But if you think about the progression in automobiles in the last decade, I think it's been really powerful, really amazing, right? Like we moved from classical cruise control, for example, to, I mean, different companies call it different things, but essentially like radar based or adaptive cruise control that can maintain speed unless there's a vehicle up ahead, can even adjust the speed, whether or not the traffic based on the traffic density, for example. So we are getting a lot closer to nearly autonomous, vehicles. And I think the social comfort level will be the final hurdle to overcome, even once we have the technology that's capable. And and humans, we humans are really hard to understand a lot. So, hard to predict when that will be. But I actually think it's going to be sooner than you think technologically, but later than you think socially.
So I know it's hard for humans to trust technology fully in that way. And technology can, of course, make mistakes. But do you feel like if every car on the road was self driving, we'd have a lot less accidents?
Oh, I do think both, there's clear evidence that that would be true, right? Like, um, that first of all, like these autonomous vehicles won't have to worry about the radical unpredictability of what typically happens on the roads, like at least roads that are out of human occupied areas like highways and things like that, right? Um, but I think there are other elements that if we if we had infrastructure that was built or updated to support autonomy, I think we'd already be there with less, in some sense, with less traffic. And I think there was a study in the 90s, somewhere in California, where they built or like cordoned off like a portion of highway to do some tests, and they did these, like, I forget the exact name for them, but when you have autonomous vehicles that are able to like go very close to each other as they're going down the road, and they have these like, dozen or so. I think the fuel efficiency was demonstrated to be ridiculously higher. And there were no accidents recorded in that study, and even though there were humans in the cars at that point, just for safety. So anyway, I think the evidence is there that we will see, like through better communication between the vehicles, through more predictability between what's happening via that communication, and or just less unpredictability from human drivers. I do think we will see safer roads at that point. Yeah.
Yeah, you bring up two great points there is not just the safety issue of that, but also the energy efficiency. So I hadn't thought about that as much, but that should help with energy and gasoline use too, if all the vehicles are driving as efficiently as possible.
100%. And I think, not only can it be already demonstrated that that's the case. I mean, I think it's when you have roads that are more safer, then we unlock the capability to um, redirect other investments that are being made is maybe what the thought that I'm thinking, right? Like, I know that there are some companies who focused their like autonomous driving trucking companies who focus on energy efficiency now, even, right? Like, how do you do better cruise control knowing the weight that's in your bed when you have a hill coming up, for example, rather than it's going to be a flat terrain, right? So I think the fuel efficiency is a in some sense, like a fiscally responsible way to push toward infrastructure change, in my view, for example. Yeah.
Yeah, so infrastructure is next is important. It's an important step for this to happen. Do you think visual AI would soon be integrated into more cities? In other words, smart cities with visual AI being integrated into the street lamps and the street signs and cameras and that kind of thing to determine traffic and all that kind of stuff.
Yeah, I think that progression has already begun. There are already modern cities, even in the US, that have hundreds or thousands of cameras. Most of them were installed for security and public safety purposes initially. But once one realizes that, oh, wait, if we actually model traffic flow through, we have all this data now, and we can connect other visual AI to understand, um, a general way of saying that is like patterns of life, right? Both from vehicles and events and humans and pedestrians and so on. Then we can um, optimize for various use cases, both safety and energy responsibility, or even just access, right? Like we have these beautiful cities in the United States that downtown areas that are often not that occupied. So we can if people feel safer, they feel the cost will be less, even just figure out how to do better parking, for example. All that will come through visual AI mechanisms that better understand and utilize the data that are available.
So all this is underway in some level or other. What do you envision, knowing how fast technology is advancing? What do you envision for the future, say, 10 years from now?
Um, well, I think I mean, it's a great question because this is such a great time to like be thinking about what's coming, right? I mean, I do think we have experienced a critical point in the development of AI broadly, like visual AI, physical AI, and so on. And that did come from the demonstration that these like super large scale models connected with vast amounts of compute and vast amounts of data were able to pull out elements from our human world that allow a better translation between the computer world and human world. I think this came initially in my sub area, like the world of like computer vision, video understanding, and so on. Like what my research group, for example, at Michigan, has focused on video to text for over a decade, right? Or an image to text. My National Science Foundation Career Award was on the image captioning problem in like 2008, right? Like, so I've seen this field grow, and I think when Clip came out, 2018, 2019, we saw this notion that, oh wait, like if you have image data, visual data, and you have language data, and they're connected and training against each other, and you're doing this at scale, there is immensely powerful structure in the model that's learned from those data. And we are now beginning to see that structure being leveraged for downstream tasks. So in the field, oftentimes these models that do these types of things at scale are being called foundation models now. Um, and when you can take a foundation model off the shelf and just make use of it for a different task for which it wasn't anticipated or it wasn't trained for, you may have to fine tune or do RAG, like retrieval augmented generation, to go and like augment what was originally in that data for a downstream task. Like that work is already light years ahead of where it would have been if you had to start from scratch. Which starting from scratch would have been, what data do I need to train this model? What's the right architecture for my model, right? And then you go and spend months or years getting that data. That's why, like, in some sense, maybe the 2010s were like the decade of large data sets in machine learning research, right? Like everyone who wanted like to get high citations on their papers were like, oh, I can just make a big data set and I'll go get a lot of citations. And I think that was last decade. And now we're in this era of, what can I do with these foundation models? And I think we're still really nascent on what's possible. But I think that inflection point, that critical change happened when we saw what things like Clip were capable of. And that structure there is just super powerful. And you see like foundation models, like Microsoft had this paper from CVPR last year, Lawrence 2, which is one of those like sort of downstream models that build up on top of a lot of data, a lot of foundational elements. And then you can query it with pretty intricate questions about the visual data, and the performance is quite strong.
All right. Well, thanks for sharing that. So, if there was one key takeaway you could leave our audience with today, what would that be?
The key takeaway that I like to end sessions like this would be that even though there's such amazing progress in AI and visual AI and so on, um, I think it's important to always remember that we do this for humans. We are humans. We're building for humans, right? Like, how can we make our society a more balanced, more equitable, safer place for everyone?
All right. Absolutely. Well, thank you so much for coming on the show and sharing your insights with us today.
Thanks, Amanda. Happy to do it.
All right. And thanks to our audience. Stay tuned. There's more.